Okay, so we're going to evaluate this limit, and the instructions say divide the numerator and denominator by the highest power of x in the denominator to find the limits. Okay, so we're going to have to do a good amount of algebra with this problem. So what we're starting with is this ratio, and the denominator, the largest power of x that appears there, is x to the 1. So we're going to multiply the numerator and denominator of this fraction by 1 over x. And when we do that, well, I want you to note that this term here in the numerator, x to the minus 1, that's equivalent to 1 over x, right? So you have to remember what a negative exponent is. So x to the negative 1 is 1 over x. Darn. Okay, let's try that again. Okay, so again, we're multiplying by 1 over x. And so when we do that, we need to distribute in the numerator and denominator. So when we multiply 1 over x to each of the terms in the numerator, we get this expression here. And in the denominator, it should be pretty straightforward. You see it's this expression, because 1 over x times 2 over x, the x's will cancel. But then when we multiply 1 over x times the second term, you know, there's nothing to cancel. It should be this. This should make sense to you. So what we need to do now is work on this numerator here. So the thing to realize is this first term in the numerator, well, hopefully you remember rational exponents. The square root of x is the same as x to the 1/2. Rational exponents, the numerator is the power, the denominator is the root. So this x is raised to the power 1, but the root is 2. So that's why the rational exponent is a half. Negative 4 is a multiplier, so that's still the multiplier here. And then dividing by x is the same as multiplying by x to the negative 1, because again, and this is the second time we're seeing this in this problem, negative exponent is, 1 over that whatever it's being applied to. So x to the minus 1 is 1 over x. So this numerator, negative 4 square root of x, is the same as negative 4x to the 1/2. And the denominator times, the denominator of x is the same as multiplying by x to the negative 1. So now when we're multiplying, hopefully you remember properties of exponents. When you multiply, you add the exponents. So when you add these exponents, you get an exponent of negative 1/2. And that exponent, negative 1/2, negative means the x is in the denominator. The power on x is 1, and the root on x is 2. So x to the negative 1/2 is 1 over square root of x, and the negative 4 is still a factor. It's a multiplier, and that's in the numerator. So that affects this first term in the numerator. And so this first term in the numerator then is what you see here. All the other terms hopefully make sense. So now we're ready to take the limit. So the limit of the given problem is the same as the limit of this new expression, because they're algebraically equivalent. And then what happens in the limit? Well, as x goes to infinity, this first term, the denominator is growing without bound, so that first term goes to 0. This other term also will go to 0, because again, the denominator is growing without bound. 2 stays the same, but this term, 3 over x, since x is growing without bound, that term also goes to 0. So in the limit, we have 2 over 0 or 0.